Hello everybody and welcome to Work Against the Grain. My name is Jeff. It's Christmas time and I wanted to see about maybe making some Christmas ornaments on the recoil on the CNC machine, the A-axis. As I've pointed out before, I belong to the Legacy CNC Woodworking training. They've got some really great training videos and files. I actually got the inspiration from their ornament here. Just great stuff. If you don't belong to this, my suggestion would be that you get in touch with them and see about becoming a member of their training, because they really do a great job. All right, so having said that, let's this pretty long video. The first part is going to be Vectric and what we did to design the ornaments and the finials. And then after that, I've got a lot of shots of the actual machining of the various parts, and you can certainly, watch those, fast forward, whatever. So the first part will be the Vectric, and let's hop in here first and have a look at how we created the ornament. So the big white area that you see is the board that I used, okay? And it is 33.5 inches long and 13 inches in the width in the Y. And mine runs X this way, Y this way. Okay, it was 1.625 or 1 5/8 inches thick. My Z0's at the bottom, lower left corner, and then okay. So what we have to do is we want to cut out two halves. And if you can picture that this piece here is going to fold over on top of this piece here, okay? And so we've got some various profiles up here, and I want to explain what we did to put these blanks together and then machine them. So this blank here represents the square blank that we are going to start with as a square blank on the recoil. And then this line here, this interior block, is we are first going to machine the square block down to that size, okay? And so we're going to have to run some G code that takes this block, and you'll see it in the video when we get to the machining, and spin it round to this. Then we're going to take this profile here, which is this one up here, and that is a plunge roundover, and we are going to have the plunge roundover bit plunge into here after it's round to create the circles. And again, this is all going to come clear to you when you see the machining video. Now, this line right here is a line that we're going to run a 1/2 inch core box bit, and these two lines down here demonstrate where that's going to cut. And you want to make sure that that doesn't cut into here, so that when you lower this bit down, you don't cut the thing in half. So we're going to machine a 1/2 inch core box along this line. And that, when we fold these two over and eventually cut the ornaments out, you'll have a 1/2 inch hole at the top and a 1/2 inch hole at the bottom of your ornament to glue your finials into, okay? So in terms of putting this blank together, now I wanted to make 7 ornaments, so I created this square block to have 7 ornament blanks. And so the first thing I did was I drew my square to say, okay, this is what I want to start with in terms of a square blank. And then I said, okay, after we take the square blank, then what we want to do is we want to come in here and machine it down to 3 inches. So let's go ahead and make that 3 inches. And then we will center that, hit shift, select the second vector, and then this will center that into that vector, okay? And so now we have our square blank, and then this is what we're going to machine to. And then we want to take our profile here of our cutter, and we're going to put that right in here like this. It should snap to that. Control and Shift creates a copy on the same plane and move that over so that they join there. Control Shift makes another. Control Shift makes another, and so on. And so you can see here that now we're creating half of our ornament blanks. Then we're going to take these and we're going to come to the mirror the selected objects, and we want to flip those vertically and then bring those down to the bottom. So now you can see here we've recreated our ornaments. Okay, now what we want to do is we want to machine this hollow so that when we flip these two blanks together, we have a hollow ornament. So I simply drew an arc and placed the arc in here. And I'm doing this kind of fast. You get the gist of what we're doing. And get that lined up best that you can, okay? And then let's go ahead and create a copy of that arc. We'll spin it around. Hold your Shift button so that it snaps into place. And then let's bring that one down here. So we're trying to machine this hollow, okay? And then what we'll do is we'll take a line segment and we'll join these two arcs together. And again, I'm just doing this fast so you can get a sense for what we're doing here, okay? And you can line that up better. But what I wanted to show you is how we're going to create this and machine this out so that it's hollow, okay? So we're going to take these vectors here and we're going to come and join them. And now we have one solid vector. Now we'll go over to our modeling. And what we want to do here is we want to create a shape, but we want to go negative. And so we want to use this profile here, and we're going to want to go minus 90 degrees. Okay? And we want our base height to be 0. We need no base height. And then we want to scale to an exact height of, now keep in mind this is 3 inches. So you probably want a 1/4 inch here and a 1/4 inch here, okay? And this will be a circle, so that's a 1/2 of an inch. So now you're at 2.5. Half of 2.5 is 1 1/4. So you want these to be 1 1/4 inches deep into the cylinder there, and we are going to apply. Start new component. So now when you come over here to your 3D view, and you take a look at this, you can see how this is dished out. Okay? Then we're going to come over here to our tool paths. We'll show you how to cut these tool paths. You're going to select your vectors here that you created around. I grouped them all together that you created around your shapes. And you are going to do a roughing cut, 3D roughing cut. And then you are going to do a 3D finish cut. And that will dish out, whoops, I'm sorry, I didn't select my vectors. Let's do that again. Select the vectors, calculate, and that will dish out our ornaments. And let's go ahead and preview the visible tool paths. There it cuts it down. There it smooths it out. Then what I did was I ran a hollow cleanup pass where I came in with a 1/4 inch end mill and just cleaned up the tops of those so that when they glued together, we got a really nice fit. And you can see how that's dished out there. Okay? All right, and that's pretty much the ornament. I mean, that kind of tells us how we are going to then machine, our ornament. So when we're all done, we've got this 2 halves that we are going to put together, right? And keeping in mind that we're going to run a 1/2 inch, you're just going to machine a 1/2 inch core box on the line, and it'll create a 1/2 inch groove that goes right down the center of those ornaments, okay? These lines here were just centering lines for me so that I knew exactly where the center of each of these were. These lines right here, we are also going to cut on the line a 1/4 inch end mill. We're going to go about an 1/8 inch deep, and that's where our finials will sit into when we cut our ornaments in half. That's kind of a guideline of how we can cut our ornaments. And then these lines right here, or excuse me, circles, are the indexing holes that we are going to drill into these blanks, so that when we flip these over, we're going to put some dowel pins in here so that when we flip these over, these dowel pins will line up with these holes, okay? And you'll see, when we get to the video of the machining, you'll see it'll all come together for you of exactly how all of this is being machined, how we glue it together, and then how we cut it on the lathe. Now, something really important is you got to know when you're writing your G code, you got to know where each of these entry points for the various cutters is, right? So you want to know that you're going to come in here 5.597 inches from 0, and that's where you're going to start your first 3-inch plunge roundover, right? Then it goes 3 inches to 8.597, 3 more inches to 11.597, 3 more inches to 14.597, and so on. And that way you'll get your plunge roundover to come in here and cut those out, okay? Now my recoil runs Y in the north-south direction, so I just put them sideways here so you could see them, but you'll see on the recoil that they actually run vertical. The long side for me is in the Y, okay? All right, then we've got some finials, and these are pretty simple. I drew a shape of a finial. You can find examples of finials online, right? Just do search wooden finial, pull it into a program, trace the outline of the finial, and then you want half of it. And let me just go ahead and show you how we did this. So we're going to use the 2-rail sweep. And so I've got a top line here, and I've got a bottom line here. We're going to use our 2-rail sweep selection. I've already selected my lines. Use selection. And we've got starting points here. You want to make sure that that's there. Then your cursor will turn into a plus sign, because it's asking you for the vector that you want to sweep across these 2 rails. You highlight that vector and apply. It'll sweep across those 2 rails, start new component, and then if you come over to the 3D view, you can see how that's going to machine. Toolpaths, toolpath drawing, wrap my X values around my Y axis because that's how mine is set up. And when you do so, you're left with a nice little finial. Let me turn the tool paths off so you can see it. And this was just an example of one of Cindy Drozda's finials on one of her ornaments. I was able to just trace the outline, and then we're going to put this on the recoil as well and do a rough cut and a finish cut so that we end up with our bottom finial. The exact same thing applies to our top finial. We have a shape here. And again, I'll show you how we sweep that. We've got a top vector. We have a bottom vector. Select those 2. Modeling tab, 2-rail sweep, use selection. Starting points are in the same place. Highlight the vector that we want to sweep across. Apply. Start new component, hit our 3D view, and we'll wrap that one as well. Toolpath drawing, wrap our X values, and there we have, let me turn the toolpaths off, my apologies. And there we have our finial that we're going to put on top of our ornament, a real simple roughing and finishing toolpath. Now, where Vectric is doing our toolpaths here for our finials, the tool paths for our ornaments, I had to do all of this manually, writing the G code, and we'll pull some of that up in just a little bit, and I'll give you just some basics. I'm no G code expert, but I'll give you some basics on what we did to write the G code so that our cutter would come to these various spots, plunge down, cut the profile, go to the next one, etc. Okay? So I tell you what, let's do. Let's hop over to the machining and let's take a look at the video, a couple of videos of how we put all of this together, how we machined it, and then kind of in the middle of the machining videos, I'll come back, show you how we programmed the G code to cut this, and then keeping in mind that Vectric, of course, did all of the tool paths for the finials. I really appreciate everybody watching. If you got any comments, please don't hesitate to ask me the questions. I know I did this fast, but shoot, I could do an hour on this, and I didn't want to bore anybody. So if you need further detail, don't hesitate to get in touch with me. I'm happy to help. This is Work Against the Grain. My name is Jeff. Okay, this is where we are cutting the 1/2-inch core box bit down the center of the ornaments to allow a place for the finials to glue to when we get to that part. So core box bit going down both pieces, and as I said, as we go through this machining, it's going to become really evident to you exactly what took place in our Vectric software. This is a Vectric toolpath that created this, right? It was on the line, we said. And we'll have a look at the next process. Okay, now in this video, you see a couple of things. We have the holes drilled here, and that's so when we sandwich these two together, we're good. Then we have the 1/4-inch piece at the top and bottom of each ornament when it's folded together here. And then this is the hollowing. Now, I apologize for this. I did two separate sets of ornaments. I did 2-inch ornaments and I did 3-inch ornaments. I did not video the hollowing out of the 3-inch, but you'll see that coming up in a minute. But it's all the same. We're going to hollow these out. This just happens to be 2-inch ornaments. Hollow these out so that when we sandwich them together, the ornaments are hollow. And that's what you're looking at here. Okay, so here we are with the 3-inch blanks, machining the little edge cleanup pass that I spoke about so that when we fold these over into each other, it's a lot cleaner. I did an extra row. I know that the Vectric file that I showed you only had the first 2 rows there. I just added a second row just because I'm going to make a couple of more. But anyway, we'll make this cleanup pass, and then we're going to utilize a profile cutout pass to cut out the 2 rows so that we can glue the pieces together and then turn our ornaments. And here we are. Everything is machined. Our holes are drilled. Our 1/2-inch core box, we've hollowed them out, and now we're cutting the pieces out that we will fold over together and glue together to machine our ornaments. Okay, so coming up, let's make some ornaments. Okay, so we took those 2 blocks we just cut out, folded them over on each other, glued them up, clamped them together. As long as this is a relatively square blank, we're good. Remember, we're going to spin this round next. So here on the ends is no big deal because it's all going to get turned round. So let's step over there and have a look at the turning round. Here is the simple rounding tool path. I've done a video on this before. Simple G code where we take that square block, put it into a 4-jaw chuck, and spin it round. And so the G code file is going through that now. And again, I'll be showing you the G code here coming up. But this is the turning round. Okay, here we have the 3-inch radius round over bit, plunging into the workplace at the dimensions that we noted in the Vectric. And I think now is a really good time to bring up the G code that we used to tell the machine exactly where to go, how deep to cut, and so on. And so here's the G code file. Sorry about the focus there. Here's the G code file that we utilize to turn this. Okay, this is the simple rounding toolpath. We put the machine in G90 mode, put our G53Z0. We told the machine to go to Y175. We told it to utilize tool 3. M3 is turning the spindle on. Then we told it to do a rapid move to, which is the G0, which is to X0, Y 1.75, and Z 1.65. And then what we're telling it here is spindle speed at 16,000 RPMs, and we want our A axis to turn at 20,000 revolutions or degrees, degrees per minute. You could divide that by 360, and that'll tell you how many revolutions it is. And now we have a feed move that while the A axis rotates 10,000 degrees, we want the Z to plunge to 1.5. And that will give us, because we Z0'd off the center of the material, that will give us, when we're done, a 3-inch round blank. Then after it does that, we want it to turn 60,000 degrees, which would be 50,000 more because we're in G90 mode. So this is absolute. So we want this to turn to 60,000, which would be 50,000 more degrees. And while it does that, we want it to move to Y29.125, and that will get our entire blank surfaced, okay? Then when we're at the end, we're going to take G53Z0 all the way to the top, which is the machine 0. Not our project 0, but the machine's top 0. M5 turns the spindle off. Then we're doing a rapid move of A back to 0 and a rapid move of X to 0 and Y back to 1.75. That is a very simple G code of taking a 3.5-inch cylinder, or 1.65 times 2, so 3.30 inch blank, and turning it down to a 3-inch cylinder. That's all the G code that it takes. And you can end it. I didn't, but you could simply type end here so that you know that the toolpath is over. And then you save this, you put it into your Mach 3, WinCNC, whatever you're using to control your machine, and that will round your blank. Now again, I caution you, I'm not a G-code expert. This is what I did. It worked for my machine. Please make sure that you understand your machine, you understand what we're doing here before you try this, okay? This was a lot of trial and error to get me to this point, okay? Then we have, as I close that one out, this is our round over. So I did it in 2 files. This is the second section of the blank. So G90 absolute, start at the very top of Z. Then I'm going to do a rapid move to Y 14.97. If you remember, that correlates with our dimensions in Vectric of where the center of our roundover bit was. I'm utilizing tool number 1. I turn the spindle on. I just make certain that I rapid to X0, Y 14.597, and Z 1.55, which is 50 thousandths above our 3-inch cylinder. I'm going to run it at 16,000 RPMs, the spindle, and I'm going to feed our A-axis again at 20,000 degrees per minute. Then I'm doing a feed move. I want Z to cut to 0.75. Now, because we Z0'd at the center of the blank, we are going from 1.55 above the center to 0.75 above the center, and we want the A-axis to spin 30,000 degrees while it's plunging to 0.75. Then when it gets there, we want to push the Z all the way back up to the top, and then we're going to rapid our A all the way back to 0. Then we're going to move 3 more inches to X0, Y 17.597, and our Z again 50 thousandths above the block. Our spindle at 16,000. Our A-axis is going to spin 20,000 degrees a minute. We're going to, again, a feed move, Z to 0.75, rotating at 30,000 degrees, and so on. Now, this is all overkill. Setting your spindle speed and your revolutions before every cut is absolute overkill. I did it because I was able to just copy and paste, copy and paste, copy and paste. I get down here to the bottom. I put my spindle M5, turns it off. I rapid my A back to 0, and I rapid my Y to 50 so that it's out of the way of everything, and then my end, okay? So that's the G code that I used to do the plunge round over bit into the material. Now, again, this was part 2. There's another file that started at, I think on our piece we started at 5.597, and then we went to 8.597, then 11.597, and so on. And this is picking it up at 14.597, okay? So that's the G-code file, and here's some more of this G-code file running on the blank. Okay, now I made these ornaments for my kids, nieces, nephews, and so what I did was a simple name lettering toolpath. That you're looking at there is a 1/32 end mill that is cutting the names into the ornaments, and then you push the pieces through and you can see into the hollow ornament with the lettering. And it's a simple text toolpath, and you simply run a profile toolpath in Vectric to cut the letters out. So that's what you're seeing here. Okay, you made it this far. I thank you very much. What we're going to do now, the next 7 video segments deal with the finials. Here is the top finial. Then you'll see the bottom finial. You'll see the roughing and finishing tool paths, as well as when I take them to the lathe and sand them and cut them out of the material block here. So enjoy that. Fast forward through it if you'd like. And then as soon as the finials are done, I'll come back, explain the assembly process, and show you the finished ornament. Okay, here is the top, or excuse me, the bottom finial all done. And then the topper, the top finial all done. And then we'll have a look at the blank all machined, and I finished it with spray polyurethane. All the names good, cut out. And all we got to do now is take our bandsaw or whatever kind of saw, hand saw you have, and cut through the middle of the ornaments there. And after you do that, what you'll see is a place for you to put your topper in and a place for you to put your bottom in. Those are my row of toppers. And then on the other side, we have my, my row of finials, or bottom finials. These are the bottoms all sprayed up with the spray-on polyurethane. And after you cut the ornaments apart and you put your bottom and your top finials into your ornament, you're left with a really neat looking Christmas ornament. This happens to be my grandson Grayson's, hanging from the tree there. And that's a, I think that's a babinga on the bottom, and then like a zebra wood top or something. I don't remember all of the woods. The main ornament body is mahogany that I used to make the ornament bodies. But I think they came out pretty good. There's some things we could have done differently that I'll come back to in another video. A couple of mistakes that were made, but this thing got so long I just I had to find a point to cut it off. So anyway, I appreciate y'all watching. Don't forget to check out LegacyCNCWoodworking.com. Vectric, of course, the greatest CNC software out there. I really appreciate you watching. Happy holidays to all of you. This is Work Against the Grain. My name is Jeff.